This Fed Gov Today program is sponsored by TrackVia. On this edition of Fed Gov Today, every moment counts in speeding up readiness for the Navy fleet.
The degree to which you can fine-tune how many tanks actually need to be re-preserved well ahead of time while it's forward deployed before she gets in the dock gives the planners an enormous amount of leverage.
Ted Lemieux of the Naval Research Lab on Fed Gov Today in just a moment. Federal programs are still running on spreadsheets, SharePoint, and systems built with old technology. That creates more work and slows things down. TrackVia Government is a workflow modernization platform that lets agencies and prime partners quickly digitize program delivery, field services, compliance reporting, and operations, delivering secure audit-ready workflows without lengthy implementations. Modern, mobile, mission-ready. Learn more at trackvia.com/government. The Naval Research Laboratory is combining commercial off-the-shelf hardware and software it's developed with industry partners to improve ship inspections. The Navy will gain several advantages over doing those inspections the old way. Ted Lemieux is head of the Center for Corrosion Science and Engineering branch at NRL. Ted, welcome. Thanks for joining me today. What was the problem you started out trying to solve to get to where you are today? Welcome.
Thanks, and thanks for the introduction. One of the things that we have to do on ships, and this is true both in commercial industry and in military ships, is that you have to inspect the ballast tanks for corrosion. Ships have all kinds of different tanks to hold drinking water, potable water, ballast tanks for true ballast, trim and list, etc. That contain seawater. There are fuel tanks, etc. Each of those is a different type of corrosive medium, and much of the ship structure is in a tank, and so corrosion of those elements is important, and there are requirements for inspection periodicity. Normally, those inspections happen by putting a human in the tank, which carries hazardous risks. People do occasionally die in tanks because of noxious gases or whatever, and it takes a lot of time. What we're asking a human to do is to a trained human to go into the tank and observe the corrosion that's in there and decide what percentage of the paint is no longer protecting it, that it's damaged. And we're asking them to differentiate between 0.01% damage and 1% and 3%. And so it's an important decisions about ship maintenance execution come out of that decision. And so it's a really difficult task. It's a dangerous task. And it takes a lot of time and cost to set them up to do that. It's about 15,000 tanks in the Navy across the whole fleet, and so you can see how that might add up.
How did you evaluate what the options were to determine what potential solutions could be either directed at this problem or put together to direct at the problem, Ted?
So all of this work began, believe it or not, in the late 1990s under Office of Naval Research Future Naval Capabilities Program called on condition-based maintenance. And we were looking at options that included the ability to assess the coating without tank entry. So you would literally just put sensors in the tank, and we developed sensors that would tell you what the corrosion state in the tank was without opening the hatch even. But in addition, we were working on other ways of inspection, both through the air, an air gap, or actually an immersion. Could you put it at that time? We were looking at ROVs, and so we looked at a wide range of options. And through the 2000s, we developed the basic techniques for both sensors and for inspection systems.
Over time, how has technology evolved in such a way that you've been it sounds like you have worked on this problem for a long time, but in the last several years, you've really closed the gap to get to where you are today. What's enabled that over the last couple of years, in your view?
Yeah, it is a bit of a long story, but the essential piece is that we had developed and delivered a capability ultimately in around 2010, and had actually rolled it out to the fleet. But at the same time, the fleet was going through a change in how it did maintenance and planned maintenance, and so to a very real extent, the technology sat on the shelf for about 10 or 15 years. And then Commander Naval Regional Maintenance Centers reached out to us about a year and a half ago, 2 years almost, that they had a ship that was forward deployed, and she had many tanks that were planned for maintenance, and they were looking for opportunity. And so they called us and asked us to use what we had developed before to go inspect those in Japan. And so we did that, but at the same time, cameras have changed a lot in the last 10 or 15 years. And so my team was also, at the same time we were doing that, evaluating some of the new camera options. And really the big change, we moved from a pan tilt zoom camera system that you literally would raster around in the tank and take 2D images of all the surfaces. And that would take about an hour and a half, to a 360 camera that has a dual lens where you get a sphere of optical data, and you don't have to raster at all. You get all of the data all at once. And that was really a linchpin, because it changed the how much time you needed, the level of difficulty of an inspection. And so literally right after we did that, the Commander Navy Regional Maintenance Center and SURF MEP asked us to begin to work out how to roll that out to the fleet. And that 360 camera system and the battery lighting that goes with it and the software really rolled out of that tech refresh that came out of that inspection in Japan.
That explains the addition of the 360 to the title of this program, the Insertable Stalk Inspection System. What did you learn from the process of doing all of this that might apply either to other things that you're working on or to other things at the Naval Research Laboratory about how potentially evolutions in technology or adding technology onto processes that are already in place might improve or accelerate development of something?
So there's a couple of ways to look at that. First, I already talked about some of the hardware things that we had learned. We've changed the hardware to a great degree, but in addition, the software, there's opportunity there that we're working towards. Originally, we were using code that was developed in-house with an industry partner that predated really any of the machine learning options that we have available to us now. And we were using color and edge detection techniques in optical images at the time. And that's still the heart of the software today. But now we have all these other tools available to us where we can recognize and differentiate structure from non-structure, or let's say sacrificial anodes, and assess them. And so we're now beginning to bring in tools that allow us to do so much more in terms of the inspection. And the last bit I would add to that about what have we learned, commercial sector pretty much headed down the same road we are. They, I think, have been pushing all along to do this on almost all commercial ships. They're a little behind us, I think, in terms of the the analysis side. But in terms of pushing the hardware and the inspection processes, they've been doing that all along. But beginning to use construction intelligence type tools where you can actually make a decision based on the data very quickly, that's where we're headed next, and really trying to get to.
When you talk about industry, you anticipated where I wanted to go next, Ted, which is how much of the partnerships with industry involved you going to them and saying, this is our problem to solve, and how much of it was them knowing kind of what the trajectory of your goals were and coming to you with solutions that maybe you didn't anticipate or didn't expect?
It's a mix, I would say. So in some cases, we have long-standing industrial, experts that we work with that work with us in our research normally, and they're an important part of the development work. But in other cases, I think, for instance, what is going on in the digital construction intelligence area, there's a whole industry working on how do I use optical information to tell what the status is of my construction program. If I walk into a room, can I tell that the door is 6 inches from where it was supposed to be? Can I give the inspector the ability to automatically annotate what he or she sees right into the digital image in the file? We're trying very much to pull from that world now and allow systems like this to do more. Trying to do what we're doing now on a ship's exterior instead of a tank, or trying to apply these same methods using the digital construction intelligence folks to paint installations and quality assurance. All of those areas is real opportunity to learn from what other industries are doing.
You said recently, Ted, advanced knowledge of tank condition allows better maintenance planning, limiting unnecessary maintenance and preventing surprises that turn into scheduled delays. It strikes me that's maybe the most important development of this, based on what Navy leadership, CNO, the Office of the Secretary at the Pentagon, and others are talking about speed and readiness all the time. It strikes me this feeds right into everything that all of those leaders are talking about, especially regarding the fleet.
Yes. So blasting and painting a tank, and especially if you're going to do 100 tanks, let's say, on a ship, takes up a big footprint in a maintenance availability planning. And so the degree to which you can fine-tune how many tanks actually need to be re-preserved well ahead of time while it's forward deployed before she gets in the dock gives the planners an enormous amount of leverage to get it right and not discover new work in the dock when she's already in the availability. And that's really at the heart of what the Navy Regional Maintenance Centers charted us to do at the beginning. They said, we want you to get us to world-class planning for tank maintenance. That was the goal. And it's all about trying to get the availability work package planning right.
Ted, thanks very much for coming on to talk about your work. Congratulations on what you've achieved, and look forward to talking about the next generation with you at some point in the future. Thank you very much.
Thank you.
You can read more about the Insertable Stalk Inspection System 360 on today's show page at fedgovtoday.com. New employees at the National Geospatial Intelligence Agency will take AI and data management training as part of the process of joining the agency. The Associate Director for Operations at NGA, Rear Admiral Michael Baker, says current employees will get training too. Michelle Atten, Chief AI Officer at NGA, will tell you how the agency's training those employees and how they'll use the training they get on Fed Gov Today TV. You can watch it now on demand at fedgovtoday.com and the Fed Gov Today YouTube channel. The next Fed Gov Today podcast is coming Tuesday. I'm Francis Rose. Talk to you then. Thanks for listening.